G'day, it's Rob here again. Well, it's Sunday morning and I'm just pottering around the shed and got a bit of free time. And I've been putting the metal lathes to work. The old CQ9325's been grinding away and drilling away, doing a good job. And the old Shorblin's also been working away, but you can see the tool post has been removed, and that's on the mini lathe. And the mini lathe's been working away as well. You can see that little quick change tool post on there. It fits really well. It actually is perfect for that lathe. It's good on the Shoblin too. I really like that little unit. It's a good value for money unit. I was actually offered a very expensive one from Banggood just recently, a new sort they've got on their website, and it's a lot bigger and a lot more expensive than this one, and I actually turned it down. I said, look, I'm not really a big fan of that type of tool post, so we'll just pass on that for now. But yeah, if you're interested, they have got another sort on there. It's not a piston or a wedge type, it's another sort, so go and have a look anyway, but it's fairly expensive, I thought. Okay, so what have I been doing? Well, let's have a look. In a previous video you would have seen where I was making up the valve unit for a rotary valve out of an old valve stem, and it's all to do with this diagram that my friend Alan from Retro Steam Tech in the UK sent me. And as you know, I make model steam engines and Stirling engines, and yeah, I've made probably half a dozen or more over the years, and yeah, it's good fun. It's a good way to try out your skills, use your lathe, don't just sit there and look at it, actually use it. And it doesn't have to be very expensive at all. You can make up this stuff out of odds and sods, and yeah. Okay, we'll come and look at this diagram, this photo he sent me. He sent me a couple actually. Now this is a photo of a little steam engine that Alan bought from eBay, and because he was curious about it, he hadn't actually seen one with a rotary valve system on the crankshaft, so that's what they've done. The crankshaft is also a rotary valve, and so you feed steam in here, or compressed air, whatever. It goes through the rotary valve, which does the opening and shutting of the valves. There's two valves in it. They're 180 degrees out of phase. So when one's open, the air comes in, this one's open, goes into the cylinder, pushes the piston back, flywheel spinning around. That valve then shuts, this one opens, the piston's now able to come back, so as the flywheel pushes it back, the steam comes back out the pipe and it goes through the open valve and it comes out an exhaust hole there. Very, very simple setup. So Alan sent me this and said, what do you reckon, you know? I think I'll have a crack at making one of these. And I said, yeah, I think it's pretty nifty. I'll have a go too, because you couldn't get much simpler or cheaper to make. Actually, really, it's pretty easy. So anyway, I'll show you another photo he sent me. This is the rotary valve unit in bits. So he's taken out the valve unit itself, which is what I machined up in that previous video, and the flywheel's off. And you can see it's just a block of aluminium in this case, with a rotary valve and some copper pipe, and pistons. So you can see it's feeding air in there. Then it goes to there, and then it comes back from there through that side port back out here and exhausts out. And I looked at this and I thought, yeah, that's pretty simple. I thought, I reckon you could make it even simpler. Because when you look at this diagram, look at the way they've engineered this, basically the steam is coming in here, through there, goes to the head, cylinder head, and then it's exhausted back. Now, whether it's fed in and exhausted at the cylinder head or just by the actual valve is really incidental, because see, basically there's no need to actually have two pipes. You can actually do it all with one pipe and have a crossover back here somewhere. So I got on Alan and said, what do you reckon about this? I reckon I could simplify this even further. Just have the one pipe. And anyway, that's what I'm doing. I've been machining up my version of this. So instead of looking like that, I'll show what it's going to look like. Now I haven't finished this yet. It's getting pretty close, but I need some more copper pipe, and this is 3/16 copper pipe, and I've pretty much run out. So what I've done was I've moved around the ports. So what it does now is it feeds in here. I've got that all set up so I can put compressed air on or hook it onto a steam boiler, which is the ultimate goal. So it comes in here, and what I've done is I've got a cross gallery between the feed and the exhaust ports. The exhaust port is now this end, not that end. The exhaust hole is down there, and a copper pipe is going, this isn't quite good enough to use in my opinion, but the copper pipe is going to go from there to the cross gallery. So basically steam will come in there on that pipe, through into the valving, up into the cross gallery, go across to the piston, the cylinder, and then as the valving rotates and the ports open and close and the piston goes in and out, it will then exhaust back through the same pipe to the cross gallery, because by now the feed pipe is shut, and it will come back and go through the cross gallery, through the exhaust valve and out the hole to the exhaust gas. So basically we can do the whole thing with one pipe and a cross gallery. So instead of having basically a junction between the two pipes in the cylinder head, the junction is now back here. So you've just eliminated one piece of pipe, basically. And it looks kind of nifty, I think. It's not bolted down; it's just sitting here. I've still got to, as I said, finish this. But basically, that's all simple machining. Very easy to do. And of course, it's also good if you can bronze braze, because you can see I've made a little, how I always make my con rods, I just make them out of a nut, 2 nuts, drill out the thread, and then I put a bolt through, Allen-headed bolt, with a sleeve over it, so it can rotate between the sleeve and the nut. So the thread's not grinding away your con rod, or your bearing area, basically. So yeah, that's as simple as you can get. And a bit of brass. So basically it should be okay, because it's with steam, because it's all brass and high-speed steel, apart from a bit of copper pipe, of course. I'll paint these. This is steel, these mounting blocks. I'll paint them, and yeah, that's where we're at. I'll turn it around, you can have a bit better look at it. The crossover pipe looks pretty cool, doesn't it, really? It looks like Heath Robinson stuff. And you can see where the pipe to the piston comes out this end of the crossover tube, the other end's a blind hole. It goes across. I originally had ideas, I thought I might have even drilled the other end out. It had a screw in and out bolt, so you could actually restrict the gas flow, the steam flow on the exhaust port, and basically speed control it as well, which I could do, but then I decided, just for now I'll do it this way, and you can vary the speed with the flame temperature anyway, or your feed in air temperature. But Yeah. Well, there you go. That'll go across, which way? That'll go across that way. So it all should be pretty neat when it's all finished, and we can drive something off of that end of the rotary valve crankshaft combination. So yeah, that's the latest project. And as I said, anybody can do this. I mean, you could do all of this with the mini lathe. No problem whatsoever, really. And I've been playing around with that mini lathe quite a bit. It's a good little machine. So what else is happening? I'll pan back. So what else have I done? Well, I've also mounted this little LED work light I reviewed recently, which is really great. I mounted that on a piece of steel on the side of the shelving here, and I can turn it on for using a bright light on the bench. I mean, that makes a big difference, you know. You can see how much that illuminates. It's a really intense light. And I've got the fluoro on over the workbench at the moment as well. So, you know, you can see that's very, very effective. So if you're working on parts, you want to get in and have a real good look, this sort of light is great. And I can take it off and move it around, put it anywhere I want, you know, drill press or lathe. But most of the time you'll be working on the bench, so I'll leave it on the bench for now. And, you know, yeah, super handy. I think that's one of the better buys from Banggood. They do have a dimmable version too, where you can use a different sort of LED. And anyway, the dimmable one, you just stroke the head and it will lower or increase the brightness. So whatever rocks you, you know, floats your boat, I suppose. Now, yeah, so I'm running out of this stuff, and you need small diameter copper pipe to make these engines. As you can see, it's a pretty small engine, you know, that's my hand, so I think I've made it smaller than the one that Alan's got, I'm not sure. Alan didn't actually, I don't think he gave me measurements, but anyway, it's a small unit. And whether it will run on steam or not will remain to be seen, but it all depends on, I mean, I'm sure it will run on steam, but how big the boiler's got to be, because, you know, the piston is, it's a reasonable size, bore and stroke on it, so yeah, it might need a really big boiler to get enough steam, we'll see. Okay, a few other things have been going on, I suppose. I'll pan back a bit more. Now, to do the soldering on the little model engine, I use this HHO generator, and it's had a problem. I've had it happen a number of times, and I've had other owners get on to me and say they've had an issue too. And it's to do with in this bubbler, there's a valve which is basically a one-way valve. So the idea of the valve is it's to stop liquid from the bubbler here going back into the unit if, say, there was flashback or something like that. That's okay, but it does two things. One is it gets stuck at times. You've got to take off the bowl, unscrew the feed pipe, loosen the valve out, clean the valve out, and put it back together, and it's okay. But then it's got a worse problem, and the worst problem is that when I went to use it, I noticed the level was right down on the internal electrolysis unit. And when I had a look, the liquid was all in here. And then another time, when I checked this, there was hardly any liquid in it, and the level here had gone up. So I thought, what the hell? Well, what's happening is that valve isn't really 100% effective. And what happens is, when you use the unit for a while, the electrolyte heats up, and then, even though you release the pressure on the torch, which I always do, to let the let the unit lose all its pressure. If that valve is stuck, the pressure won't release out. The gas or the liquid in there will cool down, and when it cools down, then it will contract, and it will then suck the liquid out of the bubbler back into the electrolyte solution, which screws up the electrolyte solution. So I had to refill, wash out and refill the unit, because all this electrolyte with borax powder in it had gone back into the bubbler. And the trick of the way around this is, after you've used it and you've released the pressure in the torch, you can either release the pressure on the relief valve here, or more simply just unscrew the cap. Just make sure it's depressurized, and then just leave the cap unscrewed. You got to leave it loose, which I do. And that way you won't get any sort of feedback or siphoning effect, But so I've written on there also where the maximum liquid level should be. That's really too high. There is better. Well, halfway's about right. And on the top here I've written, for my own benefit, slowly release pressure, loosen fill it after use. If you ever pull this valve apart too, be careful, because it's a little teeny little conical valve with a spring on it, and it only goes in one way. It goes in with the conical pointy bit pointing up. So do that, and basically if you don't get a flame, there's no gas coming out of the torch, it's because that valve is gummed up and stuck inside. But yeah, just be careful that you don't lose any bits. So that's the state of play. The little engine's coming along quite nicely. As soon as I get some more of this stuff, copper pipe, it's coming down from Queensland. I bought some on eBay, got it for a reasonable price. Trouble is, you've got to buy quite a bit of it to get it at a reasonable price. And if you try and buy small amounts, well, either nobody sells it, or you have to buy it from a hobby shop, and then they're going to, really slug you. But anyway, I got it from a plumbing supplier and refrigeration mob, and it's working out quite reasonable. Of course, once you've got it, well, then you're ready for as many little engines as you want to make, because this is basically the right diameter to get, 3/16 for this sort of scale work. All right, that's it for me. Hope you enjoyed it. We'll see you next time. Cheers.